I'm presenting our paper, Advantages of Friend-Modeled Social Interactive Feedforward for VR Exergaming. According to the American College of Sports Medicine, adults need at least 150 minutes of moderate intensity exercise or 75 minutes of high intensity exercise per week. However, 40 to 65% of people typically drop out within the first 3 to 6 months of enrolling for an exercise program, primarily because of lack of time and motivation. VR Exergaming is a promising motivational intervention to make exercising more enjoyable. The term VR Exergaming describes games that involve some sort of exercise as a mode of control in a virtual reality environment. Interactive feedforward is a novel method to improve exercise performance and maintain intrinsic motivation in high-intensity VR Exergaming. Traditional feedforward is a psychophysiological training technique in which participants observe an enhanced self-model exhibiting previously unachieved performance levels. We incorporated feedforward into the gameplay of a cycling-based VR Exergame. It enables players to interact, train, and compete with an enhanced self-model at real time in an immersive and aesthetically pleasing VR Exergame with an engaging gameplay. We recorded the performance of the players in the first session, and subsequently, players trained by competing with their enhanced self-model, moving at the speed of their previous performance at a resistance increased by 10%. Traditional feedforward uses self-modeling because studies showed that self-modeling is more effective than peer or stranger modeling, as people can relate more to their self-models. However, a closer look at the previous research suggests that the use of feedforward between people who they have an intimate interpersonal positive relationship with, such as friends, has not been investigated. This warrants the examination of feedforward in a social context using friend modeling. We investigate how effective social interactive feedforward is in improving performance and intrinsic motivation when compared to conventional self-modeled interactive feedforward. Three conditions, friend, self, and strangers, form the levels of the independent variable competitor after recording the baseline. During the baseline, we recorded participants' performance and their friends to create the enhanced models. In the friend condition, players competed with their friend's model under a 10% increased resistance. The friend's model had a picture of their friend attached to the back to help the players associate the model to their friends. In the self condition, players competed with their self model under a 10% increased resistance. The self model had a picture of the players attached to the back to help the players associate the model to themselves. The stranger condition is the control condition, and players were competing with a model which moved at the same pace as the friend's model under an increased resistance by 10%, but had a picture of a stranger attached to it to help the players associate the model to a stranger. The players were not aware that the enhanced models in the stranger condition and the friend condition moved in the same pace. Participants were informed that they were competing with a friend's model in the friend condition, self model in the self condition, and the stranger's model in the stranger condition. Our results indicate that social interactive feedforward is indeed effective in improving performance and intrinsic motivation compared to self-interactive feedforward. Specifically, our results indicate that even when the enhanced models move at the same pace, the mere association of the enhanced model with their friend results in a rapid improvement in performance and motivation, which implies that social feedforward was successfully elicited by using an enhanced friends model. Our study shows the perceived importance of exercising with a friend. Our findings are in line with the results of several studies that explore the benefits of exercising with a partner. The sample size was relatively small, mostly male and in their 20s, which limits the generalizability and implications of our findings. Longitudinal studies with larger sample sizes are required to explore our findings further. We presented only summary statistics and highlighted comments in the qualitative analysis section. We will do a detailed qualitative analysis in our future longitudinal study, exploring friend-modeled interactive feedforward. Another limitation of social interactive feedforward, as implemented in this study, is that we studied only players who have similar fitness levels as their friends. Hence, it is unclear how well social interactive feedforward works if player pairs have different fitness levels. Broadly speaking, it would be interesting to explore how social interactive feedforward and friend modeling can be used to achieve exercise adherence. This widens the application of self-modeled feedforward to a wide range of social options, which enables players to reap the benefits of socializing in addition to feedforward benefits. This method can be easily retrofitted into existing games to gain similar benefits. In our study, we used virtual avatars to represent the friend model and the performance, but still managed to evoke the benefits of exercising with a partner, shown in previous studies. This implies that these social benefits are also applicable in virtual world interactions. Thank you very much and happy exergaming.